Hello and welcome to another section in further mathematics. In this section, we will be looking at the topic probability distribution. But before that, let us look at our previous lesson. Okay, welcome back. Now, I know most of us are familiar with the word probability. Probability. I know we are very familiar with the word probability. Most times we use it in our day-to-day activities. You can tell somebody the probability of you going to the market is 0. Most times we apply it, and it definitely means that you are not going to the market. But I don't know if we really understand the context of what we are saying about probability. Today, I want us to do justice to probability so that next time, whenever we are handling the word, we know actually what we are dealing with. Now, what is probability? Now, probability is just the measure of the likelihood that an event will occur at any given point in time. When we talk of likelihood, we simply mean possibility. So if you measure the possibility of an event occurring, now you're trying to check the probability of having that event in place. So when you make use of the word probability, you're talking about the likelihood if it will actually occur or if the event will not take place. Now, probability can be applied in several areas like the education sector. You can apply probability in trying to check the possibility of everybody passing in a given examination. You know, actually those are dependent on the type of students that are in class at that particular point in time. In the industrial sector, they also apply probability when it comes to analyzing the possibility of having a very high production and comparing it with sales. They apply it in the industrial sector when it comes to so many operations in those sectors. Now, I want to tell you also that in your day-to-day activities that you perform at home, you also apply probability. Sometimes you might be asked, is it possible for you to sweep the house, wash the clothes, cut trees, go to the farm, go to the market in just one day? And you can tell the person that it's not possible. That is to say, the probability of you performing all the so above named activities is 0, because you can't do such things. Okay, at an age, remember you are still in the senior grades in secondary school. Now a question is being asked: is it possible for someone in this grade to make up to $50,000 in 2 days? You discover that it is actually not possible. So when you are talking about probability, you're trying to check the possibility of an event or a particular exercise taking place or not. Now, when you want to talk about probability, there's one thing I really want us, because of the lesson we are having with us, there's something I really want us to take into consideration, which has to do with the formula or the equation of calculating probability. Now, the only equation required for us to calculate probability is known as the probability equation, and the probability equation can be stated as number of outcome divide by the total outcome. Now we're talking about number of outcome dividing it by the total outcome. Now if you have 24 hours in a day, let's just bring it down to our day-to-day activities for better understanding. We have 24 hours in a day. Now, if you spend, let me say, 10 hours in trying to sleep, let me say you use 10 hours in sleeping the whole day. Now, if a question is being asked, what is the probability of the total time being spent on sleep? Now, the only thing you have to know is that probability of an event is, in a very rare case, can be equal to 1. So probability of an event can be 0 or less than 1. The only position where a probability can assume the value 1 is if you are very certain that that thing must happen. For example, if I should ask you a question, what is the probability of you writing the letter A when being given a biro? The probability is equal to 1, because you're no longer learning how to write A. You're no longer doing any practice in trying to sketch the alphabet A. If a biro is just being given to you, you're just going to drawing A. So the probability is equal to 1. That is to say, it is certain. Now, if I should ask you, what is the probability of you writing or creating 500 or 300 words in 2 minutes? The probability cannot be 1. In most cases, there are some persons that can write as fast as 200 words in a minute. Now, to such persons, the probability can be 1. But if you can create up to 100 words out of the total 200 words that is being required of you, then your probability will now be the 100 words that you created all over the total number of words that is being required of you, which is 200. And 0 goes with 0. We now have 1 over 2. And 1 divided by 2 is equals 0.5. So if you are being expected to create 200 words in 1 minute, and you're able to create 100 words in 1 minute, so your probability will be equals 0.5. Now, on the other way around, you spent 10 hours in sleeping out of the 24 hours you have in the whole day. So what is the probability of the total time you spent in sleeping? So the only thing you have to do is, remember, when creating your fraction, the lower number should always serve as the numerator, because if the larger number comes at the top, then your value of your probability will be greater than 1, which is definitely wrong. Probability can never exceed the value 1. So in this context, what I want us to do is, you spent 10 hours, so 10 becomes the numerator because it's a smaller number, and the larger number being the total number of time in a day, which is 24 hours. So the probability of the time, the total time spent in a day, is 10 over 24. And if you go further into breaking it down, because I told you in a previous lesson that you don't leave a fraction if it's still possible for you to break it to its lower term. Now, when you now have 10 over 24, you know, between them 2 can still divide. So you have 10, 2 goes into 10 5 times, and 2 into 24 12 times. Now remember, when you have a prime number at the top and an even number below, I stated it in our lesson 2 the other time, that it is not possible for you to break down again. So when you have numbers like this, 5 over 27, that becomes the end point of a fraction. So the probability of you spending 10 hours out of the 24 hours in the day is equal to 5 over 12. Now let's go into explanation of some terms so that we can now start solving some questions as regards to what we are having today. Now, what is a sample space? This is a set of all the possible outcomes of any random experiment. Now, when you're talking about all the possible outcome, it talks about everything. Like the example I stated here, 10 over 24. Sample space talks about the totality of the sample, and now the totality of the sample in this just concluded example is 24, because 24 is the total number of hours that exist in one day. So the sample space talks about the totality of the number that you use in performing your calculation. In the first example that I gave to you, I said if you're asked to write 200 words in 1 minute and you ended up writing 100 words, now the total number of words that is being requested from you, the 200 word, is your sample space. Why? The one you were able to create is called the event space. That is what came up from the event, what came up from your trial. So 100 becomes your event space, while the total number that was expected of you, 200, becomes your sample space. That's how it works. So when you talk about the outcome, it talks about the result of the experiment. Now I did some calculation here when I said, if you look in front of you, see 10 over 24 being equal to, I broke it down to 5 over 12. Now the outcome of this experiment talks about the answer that you've gotten. So the outcome of our experiment will now be 5 all over 12. So with this same concept, I would like us to go into solving so many other questions that has to do with probability and sample space. Let's go into solving example 1. Let me just write example 1. With this, let's say a bag contains 2 red, 6 white with a comma, and 5 black balls. A ball is selected at random from the bag. Find the probability that A, it's a black ball, B, that it's a white ball, and C, okay, let's do that of C to be not a red ball, not a red ball. Okay, let me go into writing the questions I just drafted now. We said a bag contains 2 red, 6 white, and 5 black balls. A ball is picked from the bag at random. Find the probability that A, it's a black ball, B, it's a white ball, and C, it's not a red ball. Now let's go into the appropriate concept that we need now. The first thing we have to do is to get our sample space, the total number of balls in the bag. A sample space, remember, is the total number of ball in the bag. So we now have sample space. Sample space is equals 2 plus 6 plus 5 is equals 13, because 5 plus 6 is 11, 12, 13. We have a total number of 13 balls. Our sample space is 13. Now the probability of selecting black ball, how many black balls do we have here? It was 5. I told you that time that when we have 5, that's the number that was able to be accomplished over the total. So the probability of it being a black ball, that he selected a black ball, is equal to 5 over 13. That's just it. Since we have black ball, since we are having 5 black balls in the contest, so the probability of us having 5 black balls is just 5 over 13. Now let's go to the B part of it. What's the probability of picking a white ball? Now what's the white ball? We have 6 white balls, so it just equals 6 over 13. That's the probability, because it's the total number of ball and white ball is 6. Now what is the probability of not picking a red ball? Now if it's not a red ball, that is to say he picked either a black ball or a white ball. Now we use the word or in probability symbolizes addition, then and symbolizes multiplication. So you do the probability of black ball plus the probability of white ball gives you the probability of not picking a red ball. So the sample becomes, probability of black ball is 5/13 plus probability of white ball 6/13. Now you get the LCM, which is 13. 5 plus 6 is 11. So the probability of him not picking or red ball is equals 11/13. I think I would like to say a very big thank you for being part of this lesson. To refresh your memory on what we've just discussed, please take the test that will appear very soon on your screen. Do well to use the lesson notes on the platform for a better information on the topic we've discussed. Thank you.